Finally, the last step in this spreadsheet and in VBA for now is getting our final variance covariance matrix, which, as I said in the last video, is just a matter of multiplying this bunch of numbers, that matrix, by this the transpose, this matrix. Now in VBA, this is a matter of, again, copying this code, so we're building on previous code, changing the name of it. We want to call this Varkov mmult to represent the multiplied matrix, the variance covariance multiplied matrix. And we're defining a new matrix which was dim VC, the variance covariance matrix. Again, it's two-dimensional, and VC is the array of the matrix multiplied of Z and Y. So it's not too bad, we just have to create that code. So redefine it first as its size. Now its size is going to be, now this is because of matrix multiplication, because this is a matrix that is 9 by 9 by 6, and you're multiplying it by something that is 6 by 9. So the size of the matrix you'll get will be 6 by 6. That's just the thing with matrix multiplication. Okay, so redim, it'll be the number, it'll be 6 by 6. Now remember, no col is the number of columns here at the top. There are 6 columns, so it'll be 6 by 6. So we'll do that. Number of columns, it'll be the number of columns by the number of columns. And again, it's still two-dimensional. So we want it to do 4 column 1 to the number of columns, and then 4 number of rows in the variance covariance, which is also 1 to the number of columns because it's 1 to 6. So for the columns in the variance covariance and the rows in the variance covariance, for every single column and every single row, we want you to get the VC to be equal to the column VC and the row VC, which will both be 6 in this case. We want it to do each column, get the previous VC, and add the Z, the transpose, times, so we're just multiplying them, times Y, which is the non-transpose, so that's what's multiplying. So that Y and that Z and that Y, they're multiplying those two matrices, this matrix by that matrix, and it's doing it for every single cell. So that's why it's like a loop. It's saying for every single row, do it for every single cell. So do it for every single row, and then every single VC row, and then every single column VC. And then you have to display those results. So for columns to the number of columns, and then for rows to the number of rows, similar to the last one. In that range Varkov, which we'll define now. Define that right now. So Varkov is going to be our variance covariance matrix. we want all those to be equal to our VC, variance covariance, that we've calculated up here. So this is the VC that we calculated up here. So we're saying just display it for every single column, every single row, and every single column. So up here it's calculating it. It's getting for each column and each row in the variance covariance matrix, it's adding the transpose times the original excess return matrix. So the transpose of the excess return matrix times the excess return matrix for every single column. It's doing it for every single column and row. So each cell, it's going cell by cell, that multiplied by this, that multiplied by that, etc. And then that code there is displaying it. It's saying for every column and every row, display it in those cells there, which we've defined as Varkov. So now if we run this code, Varkov mmult, there we go. That's your variance covariance matrix right there. And that's what we've tried to calculate. That's what's all been building up over the 3 weeks to write VBA code that will calculate that variance covariance matrix. And we've done it.